We're now going to see a demonstration of acid-base extraction that's very common in the organic lab. And we're going to use our old friends, fluorinone and benzoic acid. And I've made up a solution of benzoic acid and fluorinone in diethyl ether, okay, which is the solvent. You can see that diethyl ether is actually very volatile, and this was just done from swirling the diethyl ether solvent, and you can see that after it evaporates, it leaves behind the film mainly of fluorinone. At least it looks like fluorinone because it's yellow. So what we have to do is to see to it that we have enough diethyl ether in here to complete the extraction and to wash our flask down. You can see that I've washed down the solid which accumulated around the neck here. The extraction is usually done in what we call a pear-shaped flask. And the pear-shaped flask, as you can see, there you can see the reason why it's called a pear-shaped flask. It has several parts to it. It's got a stopper here, which fits very, very nicely into the neck of the pear-shaped assembly here. There's also a Teflon stopcock, and we should disassemble it to show you what it's made of. There's a piece of Teflon here. In fact, this is largely what makes the separatory funnel costly because of this particular piece of Teflon, and that's going to go in here. Okay, and that should fit in nice and snugly in there. And then what we do is we put this little Teflon retainer around there, and then there is a black washer which is put on there, and then we put a little orange nut over it. Now we've got to be careful that we don't strip the nut, because then this is going to wobble in there and you're not going to get a tight seal. Okay, so we do that, and this stopcock now is in the separatory funnel. The next thing we have to do is to check to see that this doesn't leak. And so I'm just going to put a little bit of diethyl ether in here, and you can see that there's no leakage here. Okay, you'd be able to tell, you'd be able to smell it actually. Now, let's take this out now. Let's pour this. We'll probably use this later on. Okay. Now, because diethyl ether is so volatile, we have to use funnels to make sure that we pour this material into the flask properly. Notice that this says on the side 125 milliliters, so we can't exceed that volume. I've got in this particular Erlenmeyer flask about, I would say 60 milliliters of a diethyl ether solution of benzoic acid and fluorinone. And so I'm just going to pour this in here like this. Okay. Now, because diethyl ether is so volatile, it's going to leave a film on the flask. You can see that right here. And we'll use that diethyl ether from a minute ago. Put that in there. Wash that. You can see that we've dissolved most of it, and that will pour in there. But we still have some in the neck. Now, one thing about doing extractions, you want to make sure that you get the maximum amount of material extracted. The more you leave on the sides of the flask, the less that you're going to recover later on, as we'll see. Now, I like to wash out the funnel as well. Okay, we'll get back to that in a minute. Okay. Now, benzoic acid is, as the name implies, an acid, and fluorinone is going to be a neutral molecule. When I add sodium hydroxide to this and I shake it up, the sodium hydroxide, being a base, is going to then convert the benzoic acid into an ether insoluble, water soluble salt, so that the benzoic acid then is going to migrate from the bottom layer, what looks like the bottom layer anyway right now, and it's going to go into the aqueous layer. So what we need then is some sodium hydroxide. Here we have 3 molar sodium hydroxide. Let's just make a, maybe that's about about 30 mils of 3 molar sodium hydroxide. Let's pour that in. Now, water itself is more dense than diethyl ether. Diethyl ether has a density of about 0.73 grams per milliliter, and water, of course, is about 1. And you can see now that the diethyl ether is on top and the water is on the bottom. Now, how do we know that? Because fluorinone is going to dissolve exclusively in the nonpolar water-insoluble solvent that diethyl ether is. Now, I'm going to use, instead of this glass stopper, okay, I'm going to use the cap plug that you have in your desk equipment, and I'm going to now mix the 2 layers up, okay, like that. Now, several reasons for using the plastic. Glass has a tendency to, what we say, freeze in the joint when you do extractions like this, especially with base, and so this will not, because this is plastic. Second thing is it fits very nicely, very snugly in there, so you're not going to get any leakage of either the aqueous or the organic layer. The third thing is that I can get my finger in there and I can hold it down, and I can then mix the layers together. Okay. Now, the neutralization that's going on is an exothermic process, so it's going to heat up the diethyl ether a little bit, and you're going to get a little bit of evaporation. And you can hear it if you listen closely. You may not hear it from where you are right now, but it does, in fact, give a little bit of a hissing. So here we have the 2 layers, and I'm going to only do one extraction for you right now. Okay. We take the cap off. If you leave this on and try to drain the solvent out of here, then you're going to create a sort of a partial vacuum up in here, and you won't be able to get the layers to empty out into flasks. Now, I've got here a lot of Erlenmeyers, and that's what you should have. You should have a lot of these Erlenmeyers ready for capturing this material. I'm going to now drain this, okay, after the layers are separated, and what I can say with most assuredness is that the benzoic acid is in the aqueous layer on the bottom. This is going to take a little bit of time here. Okay, there. Okay. So now I have in here a solution of sodium benzoate in water, and this has a pH probably much higher than 7. We can tell that by taking some of our pH paper, and you can see that it turns a really deep bluish color. And when I match it up with the color here, it's set that the pH is about 13, which is very strongly basic. But what we want is to acidify this so that we're going to convert the sodium benzoate back into benzoic acid, and then that's going to precipitate out. So let's see if that's the case. Let's take here we have an ice bath. I'm going to cool this down, okay, and then I'm going to add 6 molar HCl. Now, let's see what happens when I do that. Okay, cool this down a little bit, and let's put in a little bit of 6 molar HCl. Okay, there you can see that I've changed the pH of the solution enough so that now I have a a precipitate of benzoic acid in water. I can even put a little bit, just a little more, like that, and you can see I get even more of this material out. Let's cool that down, and let's check to see whether or not the pH indeed has changed. I can't. I got to get my pH paper out here. Well, that wasn't too good, was it? Okay, let's take the pH paper and check this out now. And let's see. Okay. There we go. You can see that when you match up the colors on the legend here for the pH paper, it shows that the pH is between 0 and 1, which means that we have neutralized all the base in there, and we're not going to get any more benzoic acid out than by adding more acid. So there's our benzoic acid. It feels a little bit warm. And now what we want to do is we want to suction filter this. Now you have done this in general chemistry, but here it's really quite easy because we have nice vacuum set up in each one of the hoods. Let's get all this stuff out of the way here. And here we have a Buchner funnel, and the Buchner funnel has a piece of filter paper in it that fits all over the holes that are in the bottom of this funnel. So you can see the holes, okay, in the bottom of the funnel. And what we're going to do is take this piece of filter paper, put it in there, and here we have a sidearm flask with a what's called a neoprene fitment, and this is going to then create a tight seal of the porcelain against the glass. And I usually, when I'm filtering these aqueous solutions like this, I usually put a little bit of water in there to seal the filter paper against the bottom of the funnel. You can see that right there. Okay, now I'm going to swirl this around, loosen it up, and then pour it in here, and you'll see that, in fact, the water filters out quite nicely away from the solid benzoic acid. Now let me wash this out with a little bit of water. Now benzoic acid has a certain water solubility, not a very high one, but nevertheless you want to avoid using too much water to get the residual benzoic acid out. And of course, every time water contacts the benzoic acid in the Buchner funnel, you're going to dissolve some of it, and it's going to collect down there. So this is not the quantitative operation that you might think that it would be. So we're going to okay. So we're going to let that dry. Now we're going to let the vacuum suck out as much of the water that's clinging to the benzoic acid. All right, now what are we going to do with this? What about this? Well, this is a solution. Okay, there's a little bit of water in here. I'm going to have to drain that out. But this is mainly diethyl ether and fluorinone. So what I have to do then, after I get out this water that's separated out slowly, okay, like that, I'm now going to pour this into an Erlenmeyer flask. Now since there's some water in the diethyl ether, what I want to do is to get that water out. And so we'll pour this in here, see how this works. Okay. Yeah, we have about 60 to 70 milliliters of diethyl ether in there. And I'm going to take a little bit more diethyl ether and rinse out the funnel. Not too much because of an operation in which we're going to use a little bit later to get rid of the diethyl ether and separate it from the fluorinone. There we go. Okay. All right, there. All right, so This is no longer useful for us. What we want to do now is to add some sodium sulfate. Now this is anhydrous sodium sulfate, and that means that the sodium sulfate has no water in the crystal. But if we were to take the sodium sulfate solid and put it in contact with the diethyl ether, which has a slight amount of water dissolved in it, it's going to change it to what's called a decahydrate. Now the decahydrate means that there are 10 waters in the crystal. And students always ask me, well, how much do I put in? And I said, I don't know. Put in whatever allows you to see that the sodium sulfate sticks to the bottom. Now, if you look closely to you can see that there are some sodium sulfate decahydrate clumps in the bottom, but the rest of it, when I swirl it, is free flowing. So since it's a very fast drying agent, you can say that there is probably no more water to take out of the diethyl ether layer. Okay, so we don't need this anymore. Let's get this out of the way. All right, now we're going to use in a short while the rotary evaporator, which is going to then remove the very volatile diethyl ether from the, I would say, essentially non-volatile fluorinone. And the way we do that is actually very simple. Let's get rid of this. Now I want to take this. This is going to double for a support for our funnel. I have a bunch of funnels here, but they're all essentially for the same sort of thing. We're going to put this into the round bottom flask. This is a round bottom flask, obviously because it's got a round bottom, that it has a value of 100 mils total volume. In other words, from here all the way up to here is 100 milliliters. And just like our separatory funnel, has a ground glass joint to it. Okay, that becomes important when we put it on the rotary evaporator. But what we want to do is to now transfer this into there, but we don't want to get any of the sodium sulfate solid in there. So I'm going to use a little bit of cotton. Let's get a little bit of cotton here. You don't need much. And let's see. Here's my twin blade spatula. I'm going to put that in there. All I need is a little bit, okay? So that if any sodium sulfate gets mechanically transferred into the diethyl ether, it will not go into the round bottom flask down there. Get this out of the way. And let's do this. You can see that it flows quite well. But because, once again, diethyl ether is so volatile, it leaves behind a film, and we've got to now dissolve that fluorinone swirl that around. Wait till that comes about. Away. Okay, we're almost there. By the way, you can see let's break this back here. You can see that the benzoic acid, that's the benzoic acid that I made the solution, is sort of dry. Could dry a little bit more. Okay, but there you go. There's the benzoic acid that was once in mixture with the fluorinone. And we'll get back to that shortly. All right, so let's do this. Okay, so we've managed to decant away the diethyl ether from the drying agent. Now let's see if we can get this. There we go. Okay. So here we have our ether solution of fluorinone minus the benzoic acid that we extracted out. See that? It's nice and clean too. It's so nice and clean. Okay, the next thing we're going to do is to use a rotary evaporator to remove that solvent, leaving behind the non-volatile material that's dissolved in it, namely the fluorinone. Okay, the question now becomes, how do we get rid of the diethyl ether, which is dissolving our fluorinone? Okay. Well, we're going to use what's called a rotary evaporator. Now, we have 2 generations of rotary evaporators in the organic lab, a total of 6 rotary evaporators, and they all operate on the same principle. Each is connected to a water aspirator, which produces a slight vacuum within the system, and then we have connected to the condenser portion right over here what's called a little giant pump. And what it's going to do is pump water through that particular system, making this coil cold. So what we have to do first is to load this up with a little bit of ice, okay, like that. And then we're going to put in some tap water. Okay. And we're going to start the pump. Well, you can see right away that there's water running through here quite quickly, in fact. Okay, now, there are certain steps that you have to follow in order to remove the ether successfully without getting in a lot of trouble by bumping and such. The first thing we do is to turn on the aspirator. You can tell that we're developing a vacuum. You can see that, and you can hear it too. Okay, so and this is going to be the stopcock, which is going to break the vacuum when we establish it, when we have to. Okay, here's our round bottom flask. It has about 60 to 70 milliliters of diethyl ether in it, and we're going to put this on the rotary evaporator. Now, we're not going to trust the vacuum to hold that diethyl ether on. So we're going to put one of our little blue clips on here, our little Keck clips. That fits right on there, and that's not going to fall off. We've got the system closed. Now, in order to remove the diethyl ether, we are going to evaporate it. You can even see right now that there are bubbles forming in there, and it's getting rather cold. So what we do to make the removal of the diethyl ether effective, okay, without any problems, we're going to turn on the rotary portion of it. And you'll see in a short while that this is going to start to turn. Okay, there it goes. Okay. Now we have a thermostated water bath here to warm up this flask. Remember that evaporation is a cooling process. If we were to just let the diethyl ether cool here, it would get so very cold you would see ice forming on the outside just from the condensation of moisture from our lab. So what we do then is we have a water bath which will in fact supply us with some heat to keep that at least warm enough so that we get effective evaporation of the diethyl ether. Now, if we're diligent enough, we may see some diethyl ether condensing on the coils here. That may or may not occur, but this is going to take maybe 3, 4, 5 minutes. So we're just going to let this go. Then you can walk away from this if you so choose, but remember that there are other people who want to use these devices, so don't just walk away and go somewhere for 20 minutes or so. You've got to stay on top of it and realize that you have to monitor what's going on in here. Okay. You see there's a little bit of solid that has condensed up in the neck already, and we'll just keep that in the water bath. Now I've got it thermostated for about 37 degrees, and 37 degrees is body temperature. Diethyl ether boils at 35, so that we don't need this to be very, very hot. In fact, it's better if it isn't hot, because it would have uncontrolled boiling and bumping, and the bumping would then bump into this thing that we call a trap right here. It prevents the material from getting from the flask into the rotary evaporator assembly right here in this big condenser. But you don't want to lose your material, so you don't want to heat it too hot. Okay, things are coming along here, and since we did use a substantial amount of fluorinone, the fluorinone is starting to precipitate into the cool diethyl ether, which is getting lower and lower in volume in the flask here. And you can see that. Let me just raise this up. You can see how it's starting to precipitate in there. But we're going to let this go until we get all the diethyl ether off, because that's going to ensure that it's going to be dry, and what we want is a dry fluorinone to work with. Now, sometimes in procedures you are asked to weigh the round bottom flask, because when you remove the solvent, you're going to be left with a dry solid, and the dry solid then is going to have a certain weight to it, and you will then know the weight in the flask by simply subtracting the tare, which is the empty flask, from the flask with all of the solid in it, and that's a good quantitation method. Okay, you can see we're almost there. See that? We're almost there. We'll give that just a little more time, and it will then be dry. You might want to ask, how do you know when all the diethyl ether is gone? I don't know. You just have to be patient with it. With what we have now, we've actually removed about 60 milliliters of diethyl ether in the space of about 3 or 4 minutes. So we're almost done. You can see that it's starting to cover the entire inside surface of the round bottom flask. All right, let's see if we've gotten all the diethyl ether off. So we remove this from the thermostated bath. We stop the turn that off, and now we break the vacuum very slowly. If you don't do this, there's a chance of air currents coming right down into the flask, swirling around the solid, and then blowing it back up into the trap. Okay. Now we turn this off slowly. Okay, so the vacuum is now off. We remove the clamp. Make sure now, because the vacuum is off, you want to make sure that this doesn't fall off. So we've got to be careful with that. And so here we have our solid. Now, what I've done is I've taken one of our spatulas and I've bent it. They're designed to be bent, by the way. And you can see that when I scrape this out, that in fact it looks to be quite dry. If it doesn't stick to the spatula, then it's actually quite dry, you see. And so we're going to let that dry overnight, and then we're going to do thin layer chromatography analysis to see if there's any benzoic acid in it, and also we're going to see if there's any fluorinone in the benzoic acid, which I isolated. Well, you can see there's our solid right there.